Let's talk about what are called shared work problems. And so let's paint a little scenario here. Let's say that you had a person named Stevie, and Stevie's going to clean an apartment, okay? And it takes Stevie 5 hours to clean the apartment. Now you might say that Stevie's average rate of working, so 5 hours, not hour, so 5 hours to clean the apartment. Okay, so Stevie's average rate of work would be let's try that again. It'd be 1/5 of the apartment per hour. Okay, that's his average rate of work. That kind of makes sense, right? Because after 2 hours, he's done 2/5, and after 3 hours, he's done 3/5. 4 hours, 4/5, 5 hours, he's done 5/5 of the apartment, and that's one full apartment. Okay, so he works at a rate of 1/5 of the apartment per hour. And let's say you had another person named Carol, and let's say it takes Carol 7 hours to clean the same apartment. Okay, now what would Carol's rate be? Well, if Stevie's rate was 1/5 of the apartment per hour because it took him 5 hours, then Carol's would clearly be 1/7 of the apartment per hour, right? She's working at a slower rate. Maybe she does a more thorough job. Okay, so now let's say that Stevie and Carol decided to clean the same apartment together. So let's make an observation. If Stevie and Carol work for 2 hours together, let's write that down. So if Stevie and Carol work, that is clean, for 2 hours together, okay, at the same time, they're cleaning different parts of the apartment, then, well, how much has Stevie cleaned? Well, he's cleaning at a rate of 1/5 per hour, right? 1/5 of the apartment per hour. So he's cleaned 1/5, but times 2, because he's worked for 2 hours, right? So Stevie's cleaned 2/5 of the apartment. Not quite half. Okay, this is Stevie. And what about Carol? Well, Carol's cleaned, she works at a rate of 1/7 of the apartment per hour, and as she's working for 2 hours as well, she's cleaned 2/7 of the apartment. Now let me ask you, have Stevie and Carol completely cleaned the apartment? Well, if they've completely cleaned the apartment, then when you add these two fractions together, you should get 1, right? 1 whole apartment. So Stevie doesn't quite clean half, and Carol doesn't even clean 1/3. Let's add these together just to show that we don't indeed get 1 apartment. So when we take 2/5, the amount that Stevie cleaned, and add it to the amount that Carol cleaned, which is 2/7, when we add those two fractions together, let's see, we get 14 plus 10, we get 24 over 35, okay? Now the fact that they've cleaned 24/35 of the apartment, the fact that it's not 1 whole apartment. Okay, what that tells you is they haven't cleaned the entire apartment. Haven't cleaned the entire apartment. Okay, they've cleaned 24/35 of the entire apartment. Now you might say to yourself, well, let's think of some different scenarios. You might say to yourself, well, how long would it take them to actually clean the apartment? Let's take some guesses. Let's go to another page to do this. So we had Stevie working at a rate of, we said 1/5 of the apartment per hour, right? And what did Carol work at? What was her rate? It was 1/7 of the apartment per hour. Okay, now let's say that they cleaned for 3 hours together, different parts of the apartment. Okay, well, how much has Stevie cleaned? Well, 1/5 times 3, right? So 3/5. And then if you add that to what Carol's cleaned, which is 1/7 times 3, notice how the times are the same in both cases. What do you get? Well, we get 3/5 plus 3/7. And when I add those two fractions together, I get, let's see, 21 plus 15 is 36 over 35. Oh. Now, this is a number larger than 1. That means they've cleaned more than one whole apartment, right? They've cleaned one whole apartment and they've moved on to some other apartment. So the fact that this is more than 1, when you add those fractions together, right? More than 1 means more than one apartment. Okay? So you conclude that it doesn't quite take them 3 hours to clean one apartment. It takes them more than 2, but less than 3, right? Because in 3 hours, they clean this much, which is more than one whole apartment. So you might say, I took 1/5 and I multiplied it by 2, and then I added 1/7 to 2, and then I did the same thing with 3, right? So 1/5 times 2 plus 1/7 times 2 wasn't enough, but then I went to 3, it was too much, right? 3 hours was too much. You might say, how long does it take them to actually clean the apartment? It's really hard to guess, somewhere between 2 and 3, but I'm not sure, okay? So here's what we're going to do. We're going to say, well, we're not sure. Let's say we know Stevie's rate, right? And if you multiply it by x, right? What is x? X is how long it takes to get exactly 1, right? So what you do is you multiply 1/5 times x to get how much Stevie cleans, and then you add that to 1/7 times x, which is how much Carol cleans. And when we add these together, if we found the right amount of time, what should we get? Not less than 1, not greater than 1, but exactly 1, because one whole apartment's been cleaned. You see that? This is how much Stevie's cleaned. This is how much Carol's cleaned. And if you add them together and you have just the right time, you should get 1. Well, we can solve this equation, right? So let me write this as x over 5 plus x over 7 is equal to 1. So I'm going to multiply both sides by the common denominator, which is 35. So when I take that 35, because it's addition here, you have to distribute it, right? So you multiply it by the first, multiply it by the second. Okay, 5 goes into 35 7 times, so you get 7x, plus 7 goes into 35, it's going to be 5 times, right? And 5x, and the right-hand side is 35. And now we can combine like terms. So 12x is equal to 35. Now we're going to divide both sides by 12. And what do we get? Well, let's see. X is equal to, well, 12 goes into 35. Let's figure this out. How many times? Twice, and you get 24 with a remainder of 11. Now you could write, 2 and 11 over 12, but remember these are hours, right? So, so if you say 2 and 11 over 12 hours, well, what is 1/12 of an hour? Well, that's 1/12 of 60 minutes. And 1/12 of 60 minutes is 5. So 11 over 12, right? This is 11/12. It's 5 minutes 11 times. So x would be 2 hours, right? It's at least that, but it's also how many minutes? Well, 11/12, and that would be 55 minutes. Because 11 times 5 gave me 55. Okay, so this is how long it took them to clean the apartment working together. So this is time working together. Okay, it was more than 2 hours, but less than 3. Now, we're going to do an example in a minute, but I want to just point out to you what we basically do. You take their rates, right? 1/5 was the, Stevie's individual rate, and 1/7 was Carol's individual rate, and you multiply both of them by x, because x represents that time you're looking for, right? It's the shared time. You don't know what it is, that's the whole point, but you do know when you add those two fractions together, right, you're going to get 1, because one whole job has been completed. Okay, so this is called the shared work problem, and let's take one from the beginning now. Okay, so it takes crew 1, so we have 2 crews. Crew 1, it takes 3 days to paint a 5,000 square foot house, and it takes crew 2 5 days to paint the same house. How long would it take the crews to paint the house working together? Okay, this is just like Stevie and Carol, right? Now, the way we're going to do these problems is we're going to organize the information in a little table here, okay? So when you're given a problem like this, I'd like you to create a little table like this. All you want to do is basically create 2 rows and 3 columns, okay? Now, every one of these little squares is going to have a meaning, or one of these little boxes is going to have a meaning. So what we're going to do is we're first going to label the first row as crew 1, okay? And the second one is going to be for this row is going to refer to crew 2. And we're going to have 3 things. The first column is going to be the rate. That's the first thing we want to look for. The second thing is going to be what we call the shared time. That is how long they work together for. And the last thing we're going to get is the fraction completed. Okay, so how do you begin filling in this table? First, start with the rates. Now, let's see, crew 1, it takes them 3 days. Now, this is not crew 1's rate. This is how long it takes, right? But their rate, wouldn't you say that they paint 1/3 of a house per day? Just like with Stevie and Carol, you take how long it takes them to do it, and you take 1 over that to get the rate. So crew 1's rate is 1/3 of the house per day. Now, it's true it's a 5,000 square foot house, but you don't have to worry about that. Sometimes in problems, you're given some information that's really not important to the problem. All you care about is that we're talking about painting 1 full house. Okay? Crew 2. What's crew 2's rate? Well, that's going to be 1/5 of the house per day, right? It takes them 5 days. So 1/5 of a house per day. Okay, so what are we looking for in this? We're looking for how long it takes them to paint the house working together. That's what we mean by the shared time, right? Crew 1's going to work for X hours, and the same thing with crew 2. That's what the shared time is, right? How long they work together, and that's what we're looking for. Now, fraction completed, you have to be kind of careful with these little squares here. Now, we know that we want 1 full house to be completed, but what this square refers to is how much crew 1 completes, because it's in crew 1's row. So to figure out how much, the fraction that crew 1 completes, just like with Stevie and Carol, you multiplied by the rate by how long they worked for, right? So it'll be 1/3 times x. That's what this box will be. 1/3 times x. That's how much crew 1 completes. How much does crew 2 complete? Same idea, right? It's 1/5 times x. And then you have to set up an equation that has to be solved. Now that equation, of course, is based on the fact that just like with Stevie and Carol, when you add how much Stevie and how much Carol, or crew 1, if you add how much crew 1 and how much crew 2, how much they've done, when you add those together, you have to get 1 because 1 full job has been completed. That is 1/3 x added to 1/5 x is equal to 1, okay? This is very similar to the problem we just did a moment ago. Make sure what these mean, right? This is the rate, this is the common time, plus the other rate times the common time is equal to 1. Okay, let's solve this equation on another page. Okay, so we are solving, we're solving 1/3 x plus 1/5 x is equal to 1, right? Okay, so we're going to multiply both sides of this equation by 15. Let's write that as 15 over 1. And we're going to take that 15 and distribute it. So it's going to be, let's see, 5x plus, and then when you multiply it by this one, it becomes 3x, and you get 15. So combining like terms, we get 8x is equal to 15. Dividing now both sides by 8. Those 8's cancel, and you get x is equal to 15 over 8. Now, nobody says, oh, 15 over 8 days. Let's divide 8 into 15. It goes in once. And we end up getting, let's see, 1 times 8 is not 7 last time I checked. 1 times 8 is 8. Subtract, and you get 7. Okay, so x is equal to 1 7/8 days. Now that's a little awkward, right? Nobody says 7/8 of a day. So a day, let's break it into hours, right? 1/8 of a day, right, is 1/8 of 24 hours. And let's see, 8 goes into 24, it's going to be 3. So 1/8 of a day is 3 hours. But you have 7/8. So x is going to be 1 day, right? We definitely have 1 full day. And then 7/8. So it's going to be 7 times 3. So 1 day, 21 hours. Because an eighth of 24 hours is 3 hours. And we do that 7 times to get 21 hours. Okay, so that's how you solve shared work problems. It's all about multiplying, first finding the rate, multiplying by the common time, adding those together, and then setting equal to 1, right? Because one whole job has been completed. Now, how would this problem, let's say somebody asked you, how long would it take the 2 crews to paint half of a house? Well, no longer would it be 1, right? It'd be 1/2. See, whatever you have right here is the fraction of the job that you want completed. Okay, until next time.